Okay, let's talk about angles. A review of this would be that a point, simply of no size or dimension, a line, infinitely many points, a plane, infinitely many points and lines, a line segment or segment stops and starts at 2 points. A ray consists of a point and all the points on one side, and an angle is formed when two rays intersect. So this would be the angle intersected by or formed by these two rays. Let's talk about the different types of angles that we can have. Let's see. For example, let me get a piece of paper here. Okay. For example, we can have an acute angle, which is between 0 and 90 degrees. We can have an obtuse angle, which is between 90 and 180 degrees. We can have a right angle, which is exactly 90 degrees. Exactly 90 degrees is a fourth of a rotation around a circle. A straight angle is exactly 180 degrees, and that would be half of a rotation. Okay. Now let's talk about let's also talk about the idea, the pieces of an angle. Okay. Earlier I mentioned that two rays intersect to make an angle, but there also is the idea of the initial side and the terminal side. So the initial side is your so-called start side, and your terminal side is your so-called end side. In between your start and end sides is where your angle lies. The points at which the rays meet is called your vertex. Depending on where your initial side and your start side is, depends on where your angle is. So let's talk about this idea of drawing this picture to talk about the angle. And angles can be drawn in what we call standard position. This is called standard position if the vertex of your circle is at the origin of a rectangular coordinate system, and if the initial side lies along the positive x-axis. This is the positive x-axis. This is the initial side. This is the initial side, which means this is the terminal side, and this is the terminal side. Now, if your angle opens up, then your angle is positive. So this is a positive angle. This is standard position positive. If your angle opens down, then your angle is negative. This again is standard position because the initial lies along the positive x-axis. Opening down means my angle is negative. Again, an angle is positive if generated by a counterclockwise rotation. Counterclockwise means opening up. If an angle is negative if generated by clockwise rotation or opening down. Okay, let's talk more about this idea. Measuring an angle. A degree, we know that there's 360 degrees in a circle. 1 degree would be 1/360th of a complete rotation about the vertex. Again, there are 360 degrees in a complete rotation of the circle. A right angle is 90 degrees. A right angle is an angle that measures 90 degrees. Again, we talked about this. Right angles are shown in pictures with little squares in the corner. A straight line has an angle of 180 degrees. Vertical lines run up and down, horizontals left and right. Lines are straight lines, are straight angles 180 degrees. Again, we've gone over these. Acute, less than 90 but more than 0. Straight, exactly 180. Obtuse, more than 90 but less than 180. Right, exactly 90. Okay. Let's talk about the fractional parts of angles, because you don't always have to have, for example, exactly 42 degrees. You could have 42.369 degrees. So then the question becomes, okay, well, how do I talk about this piece? How do I talk about that decimal piece, that fractional part? The fractional parts of an angle are written in measures of minutes and seconds. 1 minute, written as 1 prime, is 1/60th of a degree. And again, this is the notation. 1 prime is equal to 1/60th of a degree. A second is written with a parenthesis marks, is 1/360th of a degree. So here the question becomes, all right, how do I do this? This is the whole. The degree is the whole. The degree is the whole, so you write it as a whole. Then 47 1/2 means minute. Minutes are 60th, so 47 over 60. Then you have 12 with two marks. 2 marks means second, so that's 1/360th. I'm sorry, 1/3600th. So I have 12 over 3/3600. So I take this and I add these up. This will get my decimal form of this example. So this is equal to 31 whole minutes. 31 whole degrees, 47 minutes, and 12 seconds. Your calculator will actually do this transformation for you. But we have to know how to put it into our calculators. Now, let's say that I want to change this into its decimal form. Well, what I'm going to do is I'm going to put the 31, and then I'm going to say, you see above this button here, it says, above this button, right above this APPS, there's the word angle. So after it's second, APPS, which is angle, the very first is degree, so I'm going to hit enter. 31 degrees. Now I want to say 47, and I want to go, again, second, there's my first, my 1 hash mark, 47, and then I need the 12. Notice, in order to get the double quote, you see it's right here above the plus sign, so I have to hit alpha with the plus sign to get the double quote. I'll hit enter, and that shows me the exact decimal that I have here. Now if I want to type in 31.787, now notice I've rounded, okay, but maybe I want to change this. Maybe I want to change this to degrees, minutes, seconds. The light is hitting this funny. There we go. So if I want to change this to degrees, minutes, seconds, okay, I've typed in my number. I'm going to hit second, angle, and notice the fourth choice here is DMS, degrees, minutes, second. So I have to hit enter to pick that up. I've typed in my rounded number. I've said degrees, minutes, seconds, and here it gives it to me. Keep in mind that my seconds are off. Why? Because I've rounded. Okay, I rounded this number. I rounded this number from this one. So my seconds are off. And this is just a rounding error. But that's how we can convert back and forth between degrees, minutes, seconds, and decimal forms of angles using our calculators.